Now, you'll recall that in the previous video, we were treating basic operations of fractions. And I made it clear that there is no way we'll teach basic operations without touching LCM. LCM is interpreted as lowest common multiple. What does it mean? Because the denominator, before we can solve any of the basic operations of fractions, we must be able to find the LCM of given denominators in that given fraction. Whether the fraction is in algebraic or in numerals. Algebraic means it has unknowns, or it's on numerals, meaning it has no unknown variable. So, for instance, let's show you how to treat or find simple LCMs in given fractions. Consider, let's find the LCM of 12, 18, and 24. Let's consider that you are given an expression like this. To find the LCM tells us lowest common multiple. So look at it. First of all, whatever value you are given, check if the value is an even number. You check if the value is an even number. Even numbers are numbers that either ends with 0, 2, 4, 6, or 8. So you can see this one has 2, it has 8, it has 4. So they are even numbers. So I start with 2. What will go is 2. What will go is 2. Now 2 can go in 12. How many 2 can go in 12? 2 times 1, 2, 2 times 2, 4, 2 times 3, 6, 2 times 4, 8, 2 times 5, 10, 2 times 6, 12. How many 2 can go in 18? 9. How many 2 can go in 24? 12. 2 again can go. How many 2 can we get in 6? 3. Can 2 go in 9? No. How many 2 can go in 12? 6. 2 can still go here. So 2 can go, it can't go in 3, I write my 3. It can't go in 9, I leave my 9. In 6, it will give me 3. The next value that can go, you can see, is 3. Under verse, because we just treated 2, we check if 3 can go. So 3 can go here in 3, 1, in 9, 3, in 3, 1. 3 can go again. You get 1 here, 1, 1. So you solve till you get everything on here at 1, 1, 1. Then you know your LCM. Therefore, the LCM for this expression will be 2 times 2 times 2 times 3 times 3. So 2 times 2 is 4, 4 times 2 is 8, and 8 times 9 will be what? 2. Therefore, expressions where the denominators are 12, 18, and 24, the LCM will be what? 72. So that's how we solve for LCM. At times it can even be in numbers with x or variables. For instance, if you are asked to find the LCM of 6x, 8xy, and maybe 15x squared, for instance, the same way, because it's LCM, lowest common multiples, start with the lowest factors. Look at 6 is here, so that means it's an even number. 8 is here. So let's say 6 can go in 6x, it will give me 3x. In 8xy, it will give me 4xy. In 15, 2 can go, so I write my 15x squared. We have an even number here, so 2 can still go. So 2 go here is 3x, because it can't go. Here is 2xy, and here is still 15x squared. 2 can still go here, so 2, here is still 3x, y here is xy, and here is 15x. Okay, so what else can go? 3 can go. 3 will go, it will remain x, this will remain xy. And here, 3 will go, it will remain 5x squared. So s can, what else can go? 5 can still go. 5 can still go. Let me finish all the numerals first. Then this one will give me x squared. S is common here, s will go here 1. X divided by xy will remain y. X divided by x squared will remain x. Okay? Because look at x squared means s times x. Divided by x, 1 is to remain 1x. That's why we have it here. So the same way x can still go 1, y, and 1. Then y can now go, everything now is now 1, 1, 1. So LCM will be equals to 2 times 2 times 2 times 3 times 3 times x times x times y. So 2 times 2 times 2 is 8. 8 times 9, 72. So the answer here will be what? 72 s times s squared y. This will be the LCM. So with this knowledge of LCM, I can go back now to start solving problems that has to do with addition, multiplication of fractions. Then when we do that, with our knowledge of LCM, it will help us to be able to solve these things easily. So let's look at a few operations, basic operations in fractions. Hope you understand how LCM are gotten. So I'll be wiping this off now so that we can go back to our initial topic. All right. So having said that, let's look at other simple fractions. For instance, if I want to solve one whole number 2 over 3 plus 5 whole number 2 over 5 minus 2 whole number 3 over 6, okay, maybe of 24. How do I solve this operation? As I said in the previous class, to solve this operation, first, let's change everything to improper fraction. Change all the expression to improper fractions for easy calculation. This times this, 1 times 3 plus 2. So 1 times 3 plus 2 over 3 plus 5 times 5 plus 2 over 5 minus 2 times 6 plus 3 over 6 of 24. All right, so this is 3 plus 2 over 5 plus 25 plus 2. Sorry, this is over 3. 25 over 2 plus 5 minus 18 plus 3 over 6 of 24. Okay, this gives me 5 over 3 plus 27 over 5 minus 21 over 6 of 24. Now, of is the same thing as a product multiplier. So 6 can go here, 1, 6 here, 4. So I will have 5 over 3 plus 27 over 5 minus 24 of 4. That gives me 5 over 3 plus 27 over 5 minus 24 times 4 will give me 92. Is it 92 or 96? Okay. Is it 94? 96 over 1. So what's the LCM of 3, 5, and 1? The LCM is simple. Let me just say 3 times 5. 3 times 5 times 1, that's 15. How many 3 can go in 15? 5. 5 times 5 plus, how many 5 can go in 15? 3. It will be 3 times 27. How many 15 can, 1 can go in 15 is 15, so 15 times 96. All right, so this is 25 plus 3 times 7, 1, that's 21, carry 2. 3 times 8 is, 3 times 2 is 6, that's 81. Plus 15 times 96. 15 times 96, okay? 96, 15 times, that's 30, carry 3, that's 45, 48, then 9, then 6, then 6, 1 times 6 and 9. So that gives me 0, 4, 10, 14. So that's 14, this is minus 14, 1,440 all over 15. This plus this gives me what? 6, 10. 106 minus 1140 all over 15. You recall I've told you, anytime you have minus, it means you are owing. So 1,440, 106 minus 1,440 means it will give us minus. So let me put 106. Let's subtract. 1 here gives me 4, 3 here, 3 here, 1. So that's minus 1,334 over 15. You can go further to tell us what it is, either in whole number or in decimal. So you can use your calculator, dot, and get your final answer. It will not be a negative value of whatever you have gotten. I hope it is clear enough. Now, there are other questions we can also treat in fractions. But just as I told us earlier, we must understand the arrangement. But the word BODMAS actually shows us the algorithm or the arrangement of how the basic operations can be solved at intervals. So when we now continue treating it, we can have further expressions. For instance, let's give this question, or let's try this other question. I have 1 over 3 plus 2 over 5, for instance, bracket open, divided by 2 over 6 times let's say 6 over 15. Okay, what this means is that you solve the one to the bracket first, get your answer, divide it by the answer of this one. So let's write it. The LCM of 3 and 5 is 15. 3 and 15 is 5. 5 times 1 plus 3 and 15. 5 and 15, 3. 3 times 2. Okay, I see, open the big bracket, divided by this. I can say this will cancel this. So I'll have 2 over 15. Is that taken? So if I continue, this will be 5 times 1, 5, plus 2 times 3 is 6, all over 15, divided by 2 over 15. Okay, that is equals to 11 over 15 divided by 2 over 15. Now, for me to change division line to division to multiplication, division here to multiplication, then this denominator becomes numerator, and this denominator becomes, so I will have 11 over 15 times 15 over 2. This cancels this, that gives me 11 over 2, that's 5.5.